Welcome to the first session of this Junior Professional Legal and Regulatory Tutorial Round. My name is Jess Morton. I work at the Global CCS Institute and I'm based in Melbourne, Australia. This tutorial group has been designed to give you unique insight into topics related to CCUS, legal and regulatory developments and experiences. Not only are our lecturers based in different countries, but we have participants for this webinar from all over the world. And it's really exciting to see such an interest in CCS in so many countries and regions and have the opportunity to make some connections there. Because of this, I really encourage you to make the most of the tutorial group by connecting with each other via the internet, reading as many of the session materials that you have time for, asking the lecturers and tutors questions throughout the session, and having a go at answering the short quiz. Craig Hart will tell you a little more on the quiz at the end of the session. A different lecturer will present each week, and the lecture will be immediately followed up with a tutorial discussion. Today we'll be discussing public engagement and the regulatory process, looking specifically at a project in the United States of America called the Illinois Basin Decatur Project. This entire session will go up to about 60 minutes. But before we begin, I'd like to introduce you to our tutor and lecturer for this week. Thank you both, Craig and Sally, for logging on today. I've had the pleasure of being a small part of Sam and Craig Hart's CCUS related work over the past couple of years. Craig has a really deep knowledge and understanding of the legal, regulatory and permitting arrangements in both the USA and Asia as these relate to CCUS. Craig is a really great facilitator and he'll be your tutor tonight and for the following 3 sessions. Our lecturer is Sally Greenberg. She's a wonderful speaker and one of the world's go-to experts for insights and learnings around CCS public engagement best practice, as well as a multitude of other skills and experiences required to build a CCS project from the ground up. If you do any further research on CCS public engagement, you'll find that Sally has authored and co-authored a number of highly reputable papers. Both Sally and Craig are invaluable resources, and we urge you to take advantage of their time today by sending through your questions, which will start off the tutorial component of this session. You can submit your questions in writing through the question panel, which looks like this. We'll collect those questions during the lecture, and Craig will pose these questions to Sally once Sally has finished her presentations. So please submit your questions directly. Well, that's all from me. Sally, welcome. Thank you so much for sharing your time today, and please take over from here.
So is that my cue, Jess?
Yes, go for it, Sally.
Thank you. So it's my pleasure to be here with all of you today. It's evening where I am. I know for many of you it's morning or much later in the evening. So I think that this is a really interesting opportunity to engage with all of you on a subject that I am quite interested in and passionate about. So there's quite a lot of different pieces that will go into my presentation today, and hopefully they will come together smoothly. And as Jessica mentioned, if you have any questions during the course of the presentation, please type them in the chat window and they'll get passed to Craig, and we'll do our best to answer all your questions as we go forward. So I want to start by setting a little bit of context, and that is just to discuss briefly how carbon capture and storage projects have been handled in the United States. So the U.S. Department of Energy is really the main driver for research surrounding CCS in the United States. And several years ago, starting as early as 2002 or 2003, the Department of Energy established 7 different regional partnerships with the idea that each region has the best constraint on understanding the geology and the needs and the possibilities for carbon capture and storage within their own region. And so you see those 7 regions denoted here in various colors. So the region in which I am located is the orange one in the center of the United States, called the Midwest Geological Sequestration Consortium. And basically we are centered around one geologic feature, which is the Illinois Basin. And I'll talk a little bit about that in just a second. But each of the different partnerships has a combination of industry, non-governmental organizations, academics, geological surveys, and other government agencies associated with their partnership that has helped them develop carbon storage pilot projects on the scale of 1,000 to 10,000 tons, or large demonstration projects on the order of 1 million tons. And so as the course of this partnership program has evolved, the degree to which we have engaged in permitting and public engagement and the demonstration of carbon capture and storage has also evolved. So let me talk just a little bit about our project, because I'm going to use the Illinois Basin Decatur project as an example throughout this presentation. So the Midwest Geological Sequestration Consortium consists of the state geological surveys of Illinois, Indiana, and Kentucky, which is in the central, as I mentioned, the central portion of the United States. You can see on this map an outline of the subsurface feature, which is the Illinois Basin, which is a Precambrian sedimentary basin, which is our main target for carbon storage. Along with those geological surveys, we have partnered with Schlumberger Carbon Services and the Archer-Daniels Midland Company to do a 1 million ton carbon dioxide storage project in a deep saline reservoir. So the carbon dioxide from the Illinois Basin Decatur project is derived from the fermentation of ethanol. So in Illinois, we use ethanol as a gasoline additive for our automobiles, and we're quite an agricultural center. We grow a lot of corn and soybeans in the Midwestern United States. So the carbon dioxide is captured from the ethanol plant at Archer-Daniels Midland, and it is compressed, dehydrated, and sent to an injection site or an injection wellhead where it's injected. So if you, let's see, sorry, I lost control of my presentation there. So here's the site. This is some of the key players at the bottom picture, and then the pipeline that brings carbon dioxide from the plant to the well. We have been fully operational and injecting carbon dioxide at this location since November of 2011. We store 1,000 tons of carbon dioxide per day, and the injection period for this project is based on the volume of carbon dioxide which we will store. So I'll get into this a little bit in the details of the permit, but we are permitted to store 1 million tons of carbon dioxide. Once that goal has been met, we will shut in the well, and we will have a post-injection monitoring, verification, and accounting period, which is right now scheduled to last 3 years. So as of the time that I put together this presentation a few days ago, we had 750,000 metric tons of CO2 stored in the deep saline reservoir. So this is, by all accounts, quite a successful carbon capture and storage project. This is a picture of the site, both close up and a bit further remote. It is 800 meters square. If you look at the picture on the right, the injection wellhead is located at point C. The carbon dioxide is generated at point A, and there is a 1.9 kilometer pipeline, which is point B, which goes from the compression dehydration facility to the wellhead. Carbon dioxide is stored at about 2,100 meters beneath the surface in a unit that's about 600 meters thick. it's overlain with a 100-meter thick shale seal, and then there are 2 more primary seals in the stratigraphic column at this location. That's about all I'm going to say about the geology, but if somebody wants to contact me offline, I can give more information. Other key information that you need to know is that at point D, there is also a 2,100-meter deep monitoring well, which monitors zones inside the target reservoir where we're storing CO2. And at point E, there is a dedicated geophysical well, which allows us to do repeat 3D seismic measurements so that we can do essentially a time-lapse monitoring of the plume of CO2 as it develops. I want to talk a bit about the permitting now. So in the United States, we have quite a complex process or oversight with respect to the regulatory environment. So the United States Environmental Protection Agency, or EPA, is divided into different regions, which you see on the map with the colors. You can see Illinois is part of Region 5, which is the sort of tan-colored one in the center of the United States. That will become important later on. So, but within each region, different states may or may not share the regulatory responsibility with the federal region. And so the map to the bottom of the screen shows, for example, Illinois has its own environmental protection agency called the Illinois EPA. And this comes into play with respect to the permitting process for the Illinois Basin Decatur project. Before I go much further, I want to talk about how the different wells or the different types of underground injection are regulated within the United States. And for some of you, this may be a repeat, but for some of you, perhaps not. So the injection, the underground injection of anything is regulated under the Underground Injection Control Program, or UIC, which is part of the Safe Water Drinking Act, which states that you have to protect underground sources of drinking water. So when this governing body of the Underground Injection Control Program went into place, they devised 5 different classes of wells. So the first class is for industrial, deep, hazardous and non-hazardous industrial waste. So that's class 1. Class 2 are for wells that are related to the production or disposal of oil and gas or brine in enhanced oil recovery or enhanced gas recovery, or gas or primary oil recovery. So everything that has to do with oil and gas currently falls under class 2. Class 3 wells are related to salt mining or solution mining in salt layers. Class 4 wells are actually shallow hazardous waste wells, which are they are not permitted. You can't permit for a class 4 well. However, there were a few of those wells in place when the program went into place, so they had to have a way to define them. And then I'm going to skip ahead to the next slide, which is class 5, which at the time that the Illinois Basin Decatur project really started in 2007, actually the proposal was written in 2005, and we were funded in 2007. Class 5 was kind of the catch-all, which were for every other kind of well and for experimental wells. And recently, I'll go back to my original slide. So recently, As of 2011, the US EPA created a new class specifically related to the storage of carbon dioxide, and those are called Class 6 wells. So all of that comes into play as we go forward and tell you the story of permitting at the Illinois Basin Decatur project. So some of the aspects of Class 6 that are important to know is that there is, beyond what was required for a Class 1, which was quite rigorous and comprehensive, there's specific geologic site characterization that has to take place. There is the sense of a dynamic area of review, and an area of review is essentially the area which is covered by the pressure effect of the plume that is stored for the project. Testing and monitoring of mechanical integrity of wells, groundwater quality, tracking plume and elevated pressure. Geomechanical and seismic data that was required that wasn't required in Class 1. Extensive amounts of modeling. Then specific well construction requirements that have to do with carbon dioxide resistant materials such as chrome, steel in the well, and CO2 resistant cements. A demonstration of financial responsibility, and then an extended post-injection monitoring and site care process. So, but let me step back just a little bit and tell you how things have gone forward for the Illinois Basin Decatur project. So we started the permitting process for this project in 2007, before the Class 6 well class that I just discussed even existed. And it was in the discussion and drafting stage at that point. But we had to have a regulatory framework in which to operate, and so we, with our state, the state of Illinois, has primacy for all of the classes of wells except for Class 6. So Class 1, Class 2, Class 3, and Class 5. So the Illinois EPA, we worked with them to get a permit to inject for 1 million tons. And remember I said that it's just a volume. So typically in the past, permits have been given for a time period and not a volume period. But because this was a demonstration project, they wanted to only allow us to inject a certain volume. And so there was much discussion over whether or not to issue a Class 5 permit, which was experimental in nature because this, after all, is a research project, or a Class 1 permit, which is a non-hazardous industrial permit, which would allow us to inject carbon dioxide. So the Illinois EPA made the determination that they wanted to go with the most rigorous class of wells that had the most stringent requirements in terms of construction and monitoring, and so that was a Class 1, whereas Class 5 was not as well defined. So it was determined that they would permit us for a Class 1 non-hazardous well. Now, to make things complicated, so this was around 2008 that we 2008 that we put in our permit application, but the most recent new Class 1 well that had been permitted in the state of Illinois was permitted in the 1970s. And so that was, I'm sure, before many of you were even born. And the institutional knowledge that went along with those new permits had much of the people who had been involved had retired. And so there were existing injecting Class 1 wells in the state of Illinois, but those permits had all just been reapplications for an extension of the permit that already existed. So we had to operate, we essentially had to work with the regulators to develop our permit application and then negotiate with them the conditions of our permit based on a whole new set of understanding about the activities that were going to take place. So that all happened, and we got, it took quite a long time. It took a couple of years to get a permit one issued. And then we drilled all the wells that we needed to drill, and then there's a whole lot of information you have to give back to the EPA in a report once you have constructed your location, and then they give you a final permission to inject, which happened in November of 2011, and we started injecting. But at the same time, in 2010, the Class 6 rules were finalized, and so there was a legal requirement that any injecting CO2 project had to submit a Class 6 permit to the federal EPA by December of 2011. And so we have at present a Class 6 permit pending with the U.S. EPA Region 5. And I'll get to that, I'll go back to that in a little while. But I'm going to move away from the regulatory context for a minute, and I want to give you some background on best practices and some thoughts about public engagement, and then I'll bring those two subjects back together at the close of my presentation. So public engagement is something that we here at the Midwest Geological Sequestration Consortium and as the operators of the Illinois Basin Decatur Project feel is quite important and have dedicated a considerable amount of time to over the course of the project that we have been involved in, and in the establishment of carbon capture and storage in our region and in the United States throughout the time that we've been engaged in this research, which has been since 2003 and actually even a bit before that. So just to give you a sense of sort of where the international thought on different legal, regulatory aspects and best practices think about the role of the stakeholder or anybody who has a significant stake in the activities of what is happening with the CCS project. So IEA Carbon Capture and Storage Legal and Regulatory Review put forward this statement that the focus so far on stakeholder engagement has been focused on the project developer. So that would be somebody like me. And that they call for a shift to government and regulations to manage the role of stakeholder engagement or public engagement. And they pose these questions about whether or not it's more beneficial to have public engagement undertaken by the government, or what is to understand what is the impact of regulations on engagement, and whether or not the CCS laws or legal framework is in place to foster engagement or force engagement, and then how do stakeholder perceptions of CCS impact that framework. So that's some of the international thought and discussion that has gone on. There are many, many different ways and approaches to public engagement out there. And some of the best work that I have found that relates specifically to carbon capture and storage, but also to public engagement in general, comes from these sources. So the World Bank IFC group has done a lot. IAP2, which is has international public engagement guidelines, and then the World Resources Institute several years ago published a set of guidelines both on carbon capture and storage and then subsequently on community engagement. And those guidelines were created through an expert solicitation process where they had multiple groups of experts who participated in discussions about best practices and debated hotly a lot of the issues around CCS and framing that in the legal, regulatory, and project developer roles. An additional source and I participated in the World Resources Institute. I think Craig may have also participated, but he can mention that when I give the stage back to him. So, and then also there is a document that was put together by the U.S. Department of Energy Outreach Working Group, of which each of the projects or partnerships, such as Midwest Geological Sequestration Consortium, has a member. And so we got together and wrote a set of guidelines for public outreach and education for carbon storage projects. But at the end of the day, all of these resources basically say the same thing, that the key to good public engagement is investigating the environment in which you're operating, adapting to the needs of the stakeholders in various environments, and engaging people in two-directional listening, talking, sharing of ideas, and fostering engagement. So at its simplest point, those are the keys to public engagement. I want to go a bit into some of the work that was done by the World Resources Institute because I think it plays nicely to this discussion today. And the World Resources Institute basically says that there are 3 key groups that need to be at the table when it comes to public engagement: local decision makers, project developers, and regulators. And I'd like to thank Sarah Forbes for the use of these slides. But they go on to say that successful outreach and engagement around a project, such as the Illinois Basin Decatur Project, does not necessarily translate into successful deployment of CCS. And we can talk about that a bit later. We have been quite successful in engaging the public, but that hasn't impacted our ability to do or not to do our project, whereas other projects have had a considerably different experience with respect to the public and the license to operate in that community. Community engagement cannot happen if the community perceives it does not have the ability to influence the decision-making process. So if there's no place for engagement with the public, then you will automatically have people who are disenfranchised and who feel that the project or any project is unapproachable. And so there needs to be ways which the community can engage to inform project design and operation, and ideally with the goal of a mutually beneficial outcome. Trust is key to successful engagement, and trust happens in lots of different ways. Sometimes it's the provider of engagement and information that is a trusted source. Sometimes it is a factor of building relationships that fosters trust. But trust is hard to gain and it's easily broken. So it's a very, very fragile aspect of public engagement that needs to be minded and tended quite frequently. Public engagement is affected by the local and regional political social dynamics. And the structure of the engagement process itself is also important. So this kind of speaks to the idea that when you start public engagement and how you do it matters. And that is a very, very difficult thing to gauge on for a lot of reasons. Engagement and outreach cannot just be an add-on or an afterthought. They must be an integrated part of the process. One of the things that we've done at the Illinois Basin Decatur Project is that we have elevated public engagement, communication, and education to the project management level so that all of the decisions that get made with respect to the project happen with the idea that public engagement is an important component. And so I'm present at every meeting. I help manage the project. I always have a voice in the idea of saying, wait a minute, these are great scientific results, but how do you think the public will respond, or at what point do we need to provide this information to our stakeholder audience? So, and then for us, the starting point for stakeholder engagement was essentially these caveats, and that is that there is no guarantee of public acceptance of carbon capture and storage. Stakeholder engagement can help us identify a community's concerns and questions. The relationship between us, the project developer, the regulators who have the job to regulate the safe storage of carbon dioxide, and the community is a critical component. If we don't do public engagement, the public will form their own opinion of CCS without any information or informed discussion with us. And regardless of what we perceive of from a technical perspective as risks, the public has their own sense of perceived risk, which are no less real and can rapidly transform into public opposition if they're ignored. So our objectives have been to create knowledgeable stakeholders, to inform the public about potential project risks and benefits, present a trusted project team, and to engender that trust with the community and the people who are involved in the project, that the information that we provide is based on scientific information. So it's based in fact and is simplified and presented in language plain language that everybody can understand. And that we really engage in a sense of two-way communication. So it's not just me telling you what you should know about carbon capture and storage, but you telling me how it makes you feel, what you think, what are your concerns, asking your questions, trying to understand the process, and then based on that dialogue between you and me, then we can start to gain some of this sense of trust and informed stakeholders about risks and benefits. So some of this is actually quite challenging because we as project developers and as technical people tend to see carbon capture and storage as a solution or a bridge. And we are very systematic about our approach. We base what we say on geologic knowledge of the subsurface. We know that what we're doing is based in long-standing industrial processes, and we actually are quite confident in carbon capture and storage as a viable technology. But that may or may not be what the public thinks. So there's a variety of opinions. Some people think that carbon capture and storage is just another excuse to continue the use of fossil fuel. Some people don't like the way that carbon capture and storage projects have been introduced to a community. There's a lot of conflicting messages where sometimes you'll see that there's no such thing as clean coal and coal is terrible, and then balance that with the message that in the United States, for example, there was a period of time where we were very keen to demonstrate that we could be energy independent of the rest of the world, and so coal was our opportunity to do that. So the point here is that when you're doing public engagement, you're operating in an environment where there's lots and lots of different views, and so you have a responsibility in the way that you engage with people to be respectful of those views, even if they're not your own. So let me now bring it back to the regulatory process. So the regulatory process in the United States has a formal public engagement process, and that process is outlined here. I'm just going to take a sip of water. So when you submit a permit application to the EPA, they make a public notice in the newspaper that there has been a permit application submitted. Then there is a defined comment period in which people can go to the local library, read the permit application, submit questions to the EPA, submit statements of opposition, whatever they want to say, they have the right to say. The public can also request a public hearing at that time, which means that the EPA and the project developers have to appear at a meeting and talk to people in person. There's also a prescribed amount of time. So the public comment period is 30 days. The request for a public hearing, you have to have 45 days. Then you host a public hearing. After that public hearing, there is a additional 30-day comment period, which then closes. The EPA has to, in writing, respond to all of the comments they've gotten on the permit, and then they issue a draft permit related to the permit application. And if you have made comments during the public comment period, you can then comment on the draft permit. But otherwise, that third public comment period is closed. And then there is one additional round of response to comments by the EPA. And then there is finally a public appeal period, which is another 30 days. So this can take quite a long time. Its shortest duration is about 120 days. But it can take considerably longer than that, depending on how many comments there are. A typical strategy is for people who are not in favor of a project to wait until the final hour of the comment period to submit their comments, which then delays the EPA response. And so you can see that this is, and then there's also, I would just say, a sort of strict adherence to protocol that's followed at the public hearing. So it's not necessarily the most flexible or informative way to engage the public, but this is the process that exists around the permitting process. But what we have found is that you have to do a considerable amount of informal engagement as well, which requires certain characteristics like flexibility, awareness, respect, intuition, adaptation, and knowledge. You need to be able to talk to this little girl, to her parents, to community leaders, to non-governmental organizations and all of those people may have different needs and different information requirements based in around which you need to engage. So I want to talk just briefly about some of the things that have worked for the Midwest Geological Sequestration Consortium, and STEP, which is my educational program funded by the Department of Energy, the Sequestration Training and Education Program. Some of you may be familiar with it. We began engagement early. We had been doing public engagement long before we got a funded carbon capture and storage project. We made public engagement a priority, which I mentioned before. We integrated public engagement into all aspects of our project management. We made a sufficient and quite extensive investment in time and resources to engage the public and to talk to a variety of different stakeholder groups. We sought to understand the community in which we operated. I will say this, that's made easy by the fact that I live 45 minutes away from the Illinois Basin Decatur project site. So when people ask me, hey, would you store carbon dioxide under your house, I can honestly say to them, yes, I would, because we're talking about the same rock units, only 30 or 40 miles away. We consulted the community, we listened to them, we talked to them about their concerns. We created, evaluated, and refined our communications and engagement plans as we've gone along. And each stage of a project has different requirements or different needs with respect to public engagement. So it's not just enough to do public engagement at the very, very beginning, but you have to do it throughout a project. So now that we've been injecting for almost 3 years, it's quite a different kind of engagement than we used to have, but still we have a responsibility to do that and to answer questions and to provide information about how things are going with our project. And then we monitored and adapted our public engagement program as we went along and as needed. And so a lot of that requires that sort of awareness or diligence to watch what's happening in the newspaper, watch what's happening in the CCS community internationally, what's happening in the United States. What information do we think that those who are impacted by a project such as our project need to know, and how can we engage them proactively rather than defensively? And one of the things that I like to share with people, because I find this to be one of the most interesting things that outcomes for me for the process of public engagement. And I didn't say it before, but I'm also a geologist, and so I come at carbon capture and storage from a technical perspective and from a social science perspective. So I really feel quite privileged to have these two lenses with which to look at things. And so what I have found is that the questions that you see listed here, such as how do you know the CO2 stays where you put it, what happens in the event of an earthquake, where does the water go that's in the reservoir, the formation water go, are you going to fracture the rocks, are you fracking, what are the long-term implications, who's responsible, who's liable, how do you know it's safe? Those questions are similar, if not the same, to the technical questions that we ask ourselves. So how do you know where the CO2 is, that CO2 is staying where you put it, is the same question as what is your monitoring, verification, and accounting program? How are you accounting for the stored carbon dioxide? What are your monitoring methods? How can you tell if there is CO2 introduced to the soil zone from your project? So that's a question that we as technical people are asking ourselves. What happens in the event of an earthquake? So what is the geophysical activity? What is the background microseismic activity in the area? Has your storage impacted that at all? And how can we use geophysical methods to tell us where the CO2 is stored? Does CO2 injection fracture rocks during injection? This is a question that you actually have to answer in the regulatory process, because you're required to state what the fracture gradient of a rock is, and then you're required to inject at 80% of what that maximum pressure is. So we can always say, no, we're not fracturing the rock. In fact, if we are, we're in trouble. So this just gives you a sense of the kinds of questions that get asked by the public, and how somebody who's in my position or who's related to public engagement needs to be able to answer. But these are also questions, if you think about it, that to some degree the regulatory process is designed to help answer as well. And then this is just a little shout out to some of the strategies in terms of public engagement. So this is a figure that I actually, as a technical person, really, really like. It talks about the compressibility of CO2 and the volume difference from CO2 gas at the surface to the volume of CO2 supercritical fluid at depth, a depth of 2.5 kilometers. And this is a figure which was, I need to give credit to the CO2 CRC in Australia. I borrowed it from them. But somebody said to me, essentially 1 cup of supercritical CO2 equals 277 cups of CO2 at the surface under atmospheric pressure. So that's kind of an interesting metric, but it's a little bit hard to wrap your head around. So if I'm the public, something like this makes much more sense to me. 277 cups of CO2, or coffee, gaseous coffee, I guess, to be more correct, is the equivalent of 1 cup of CO2 stored in the subsurface. So part of the public engagement skill is taking this information and making it accessible not only to the regulators but to the public. And that is a lot of what you have to do, is sort of in this translational space of making concepts and difficult topics accessible. So here are some of my take-home points about public engagement. I think it's critical. I think there are projects that provide successful examples of engagement. That doesn't necessarily mean a project has to have a successful public engagement to go forward, but it certainly is the preferred way to go. What I think you need to do for public engagement is you need to do your homework. You need to understand the community. You need to establish relationships. You need to talk a lot, which you can tell I'm very good at, to as many different people and as many different stakeholders as often as possible. People don't often get new concepts the first time you talk to them, and we found this to be true not only with the public but also with regulators, where we had to revisit subjects over and over again in order to be able to gain some sort of mutual understanding. You need to know your audience, know your topic, be prepared, listen, respond appropriately, and respectfully. So let me go back. I'm almost done. Let me go back to some of the things that we learned about in the Illinois Basin Decatur Project about the regulatory process. And that is that regulations, to some degree, will drive your monitoring activities. So they'll drive your ability to answer the question of how do you know the CO2 is being stored safely. That those monitoring activities are ongoing and evolving, and research hasn't necessarily defined which monitoring requirements or techniques really are the most valuable. And researchers are in this sort of weird space where you are trying a whole bunch of monitoring techniques, but you might be obligated as a project developer in the future to do some monitoring which may or may not have any impact on your ability to monitor CO2 very well in an area. Another thing that we have found is that environmental baseline with respect to monitoring is essential regardless of the regulatory requirements. And that, excuse me just one minute, and that we have been collecting environmental data as long as we have been in the permit application process, long before the Illinois Basin Decatur Project started. Because the only way you're going to be able to demonstrate whether or not your activities have had some impact or you have CO2 leakage is if you understood what the environment, and that would be the deep subsurface and the near subsurface, look like with respect to carbon dioxide signature before you start the injection of CO2. And so you need to be able to demonstrate whether or not what you're doing has had any impact. Similarly, the public engagement guidelines, as I provided in an example, should be exceeded. If you stick strictly to that formal process of public engagement, there is by no means enough opportunity to engage with the public, to have them understand what you're doing, why you're doing it, to ask their questions. There is so much more needed with regard to discussing the activities of a carbon capture and storage project than what happens in the formal permitting process. It's important with respect to a regulatory permit or a permit to inject CO2 that you provide a balance of information. You need to be, detail is important, but it can also distract. And what I mean by that is that as a research project, much of what we have done may or may not be significant to a commercial CCS project who's permitting a project after us. Modeling is becoming a key component, and that there will be, it's expected that there will be generation of new models and verification of those models. It's important to proactively engage with the regulators and to do it early and to familiarize yourself with the regulatory time clock. So if you're a project developer and you think that you're going to be able to get a permit very, very quickly and you're not familiar with that public engagement process, for example, then you are going to experience significant delays. And then again, similar to what I said about public engagement, you can think of this in terms of regulatory engagement. You need to start early. You need to seek out examples of other regulatory, other CCS permits that have been submitted, and you need to remain flexible. You may or may not get exactly what you want out of the permitting process. I'd just like to, I'm just about finished. I just want to say that the work that I do is supported by the U.S. Department of Energy on the Sequestration Training and Education Program. We hosted the International Summer School a couple of years ago here in Champaign, which was a huge privilege. And we have a variety of other programs. So if you want to check out our website, which is www.sequestration.org/step, I would be delighted. And if any of you want to contact me for any reason, please don't hesitate to do so. Also, I'd like to acknowledge that the Midwest Geological Sequestration Consortium is funded by the U.S. Department of Energy through the National Energy Technology Laboratory and the Regional Carbon Sequestration Partnership Program, and with support from the Illinois Department of Commerce and Economic Opportunity and their Office of Coal Development through the Illinois Clean Coal Institute. We're doing work currently with the Koreans on a carbon capture and storage project, so they've supported some of our work, and then the other acknowledgments for donations that have taken place. So with that, I want to leave you with this final thought, and that is, you hear a lot about public acceptance, and you hear a lot about public engagement, and I just want to say, and it's often, public acceptance especially is referred to as a barrier, and I would just like to leave you with this idea that public engagement around issues of energy and the environment represent important opportunities to build greater understanding, not only for the public but for ourselves. And communication is never a barrier. It is always an opportunity in which we must go forward in order to get the license to operate. So with that, I will turn it over to Craig and the panelists to answer any questions.
Thank you, Sally. That was a terrific presentation. We've had about 24 questions during the time that you were presenting. We may have more come in. What I've done is I'm going to bundle these in categories for you, and I'm going to give them to you a few at a time, if that's okay.
That would be great.
They fall into, so far, they fall into about 4 different types of question. And we're going to start off with questions about public engagement. So there are several questions here. How does the public find out about the permitting process and engage it? Is the EPA using other media other than newspapers and libraries to notify and make documents available? Is public engagement, in your opinion, would primary schools be appropriate to reach out to the public? And then can you talk a little bit more about the transparency in the Decatur project in relation to your public engagement efforts?
Wow. Okay. Could you read the first 2 questions to me again, Craig?
Sure. How does the public find out about the permitting process and engage it? And is the EPA using other media other than newspapers and libraries to notify the public and make documents available?
Okay. So the way that the EPA, the way that the Illinois EPA notifies or is required to notify is that they put an announcement in the local newspaper, and then they pick some location where they have a physical copy of the permit application on file that people can access. So primarily that's done through a newspaper announcement, and then also I think probably they make some sort of announcement on their website. But that's really all that they're required to do by law. U.S. EPA in the Class 6 process has engaged in the additional outreach related to issues of environmental justice. And so they will have additional information sessions if they believe that an area meets certain criteria for environmental justice concerns. So there's not much that happens that is required to happen in the regulatory process with respect to public engagement. So Craig, can you give me the next couple?
Sure. Do you think primary schools are an appropriate venue for public engagement? How would you use them?
So here is my thought about education. And as I have, so I've been working in CCS since 2004. And I started really by doing outreach and education. And so over time, public engagement to me has kind of become this confluence of communications, education, outreach, engagement, and then to some degree project management and regulation. So it's quite conflated by all of those things because I've done a bit of all of that. So, but to the question about primary school, what I think is appropriate for primary school is science education. So it is appropriate to talk about what kind of science is happening, and science and society in the United States is one of the big goals in terms of our educational standards. So, but I don't think it's appropriate to go and lobby school children about something that you then expect them to go home and tell their parents that this is a good idea. It's purely from a science learning perspective that I would go into a primary school.
Thank you. Okay, now, Sally, the next batch of questions concerned how the general public views regulation as well as the potential for legal action. I'm going to read these to you. They are related to the public engagement process, but now the first question is, does the general public ever raise any questions about legislation and regulation for CO2 storage, or is it mainly about the science and economics of CCS? And then the second related question, is it possible for a member of the public to take legal action against a proposed project? In Canada, for example, if a member of the public can prove they are directly or adversely affected by a proposed project, then the project goes to a hearing and can be denied approval based on the concerns of the impacted individual.
Okay, so yes, the public raises questions about legislation or regulations. In many, many cases, I would say the majority of the general public in the United States does not know that there is such a thing as the underground injection control program, or that the underground injection of anything takes place. And so for the most part, people are quite unfamiliar with any regulations that are in place to protect their drinking water. That said, the purview of the U.S. EPA with respect to CCS really only relates to the subsurface, and so that's something you have to discuss with people back and forth. In terms of legal issues, they get raised, but there is not necessarily any legal framework in place except laws that already exist that relate to similar things with respect to CCS, like trespass and damages. And so one of the main differences, and now this gets a little bit to the second question with the Canadian example of, the public can comment and they can argue against or present information against a project. But the difference between Canada and the United States and many other countries around the world is that in Canada, the Crown owns the subsurface. And in the United States, the surface owner or somebody owns the rights to the subsurface. So when I buy a house, I technically own the rights to beneath my house, to the heavens, to the center of the earth. So if I have minerals under my house, like oil or gas or coal or something like that, I can sell those rights to somebody else so that they can be mined and I can earn money. So that's a big, big difference with the United States than many other countries. And so then because the surface, or because the subsurface is essentially can be owned by many people, then one individual member of the public probably couldn't stop a project for legal reasons. Sort of along the lines of the example that was given.
Sally, the next batch of questions concern the Decatur project specifically.
Okay.
Now, we're planning on going to 20 past the hour.
Okay.
And there's still two more categories of questions to go. We're going to do our best.
Was that a hint to keep it short, Craig?
No, it was just to give you a kind of an idea of time, because we're going to try to get to everyone's questions.
Okay.
So at Decatur, and some of these are things you've touched on, but you might want to just confirm them for everyone.
Okay.
Is it a deep saline formation, or were there any depleted oil gas reservoirs involved in the sequestration phase? Is there any shale gas or fracking activity in the area, and how would those have impacted your storage? Then what is the technology and solvent used in the ethanol plant for CO2 capture? And I'm going to hold with those, and then I'll go on with some more of the questions about the project.
Okay. So it is a deep saline storage project. There is no oil recovery or fossil fuel recovery associated with the Illinois Basin Decatur project, although the Midwest Geological Sequestration Consortium did do some enhanced oil recovery pilots, but just not at this location. And there is not any producible oil and gas in this area. Also, along those lines, there's no shale gas or fracking activity in the area. It's just recently started to be discussed in Illinois. And we don't actually, although the Illinois Basin has rocks that may be suitable for the production of shale gas, again, in this location, it's too deep, and it's not the right environment for that. And then with respect to the solvent that's been used for capture, so because this is CO2, which is generated in the fermentation process, essentially we're getting food-grade CO2 off of the fermentation process, which is just captured and sent directly to the compressor dehydration. We don't need any solvent to separate or to do anything with the capture process.
Thank you. Can you give us some information on the conditions of the injection, specifically compression, discharge pressure, or pressure at the basin? And did you detect any leakage in either the transport or the storage stage?
Okay, so there has been no indication, no out-of-bounds conditions. We have no indication, or we're quite confident that there has been no leakage associated with either the surface activities or the subsurface activities. CO2 comes off of the fermentation process at essentially atmospheric pressure. It goes through a 4-stage compression dehydration process in which it is compressed to about 1,400 psi at the wellhead.
Thank you. Okay, a few more questions on the Decatur project. Are there any other plans, future plans for CO2 injection after achieving the 1 million ton target? Another question, I believe there is a second source of CO2 to be linked to the Decatur injection. What is the thinking behind this if the permit limit volume is already mostly used up?
Okay, both of those questions are answered by the same answer, and that is that there is a second project that is underway in which we at the University of Illinois and the Illinois State Geological Survey are the principal investigator on the Illinois Basin Decatur project and in charge of the leads in the Midwest Geological Sequestration Consortium. On the second project, Archer Daniels Midland, who is our industrial partner on the first project, is the principal investigator for a second larger scale injection project called the Illinois Industrial Sources CCS project. That project, there is another separate injection well and monitoring well, which are located less than a mile away from the Illinois Basin Decatur location. And the idea originally was that we would have 2 projects that were capturing CO2 from the same source, and we would have the ability to inject CO2 in 2 wells and model the interaction between 2 plumes in the same subsurface reservoir. That project is in the Class 6 permitting process right now, and they are actually ahead of us in line with respect to the Class 6 permit. So it's likely that they will get their Class 6 permit, but we will be done injecting by the time that they get that permit. So that dual monitoring of the plumes is probably not going to be possible. So once the Illinois Basin Decatur project, 1 million tons, is finished with injecting, the industrial sources project led by ADM will take that 1,000 tons a day plus another 1,500 tons a day, and they'll be injecting at a larger volume of about 2,500 tons a day, so that you're more approximating 1 million tons a year, which is gets us closer to understanding what happens at the commercial scale.
Thank you. We have a few questions about the permitting. You mentioned the extensive requirements in permitting. What has been the biggest obstacle to overcome in the Class 6 permit process? Another question, I think related, is it was mentioned that the post-injection monitoring period will only be 3 years. But based on my understanding of the EPA regulation, a minimum time frame of 50 years is required. How did your project justify the 3-year time frame in the permit?
Okay, so here we have a little bit of a timing issue. So when the Illinois Basin Decatur project was designed and proposed to the U.S. Department of Energy, we proposed a 3-year post-injection monitoring period. So when we wrote our permit application to the Illinois EPA, there were no Class 6 post-injection site closure monitoring requirements, which is where that number of 50 years starts to come into play. So we don't know what the Class 6 process is going to say and how it's going to impact our post-injection site monitoring, and that's one of the big unknowns. And so that leaves us in a sort of limbo, if you will, with regards to what is going to happen as we go forward with the Illinois Basin Decatur project and the Industrial Sources project. One comment about the 50 years, it is 50 years or at the discretion of the director, which means that you can, if you can demonstrate that there is no longer a pressure impact in the reservoir, then you might be able to shorten that post-injection site care requirement from 50 years. That's yet to be tested. And to the question about what is the largest obstacle, I would say not so much obstacle but challenge is that the largest challenge has been permitting an existing operating project and in an emerging regulatory framework. So the regulatory framework has changed as we've gone along, and this research project is being held to commercial CCS standards which are designed to regulate CCS projects which will be in operation, or power plants that will be in operation for 30 or 50 years. And that is just not the scale at which a project such as ours, which is designed to answer questions that could inform the regulatory process, but that process started to happen much more quickly. And so the work that we've done has, while it's important, has not necessarily been taken and looked at with respect to how can that be utilized in the regulatory process.
Thank you. Now that leads into the next question very well. Had a liability transfer scheme already been set up before you started injecting at Decatur?
Again, not a requirement of the Illinois EPA Class 1 permit. The way that our permitting process is for Class 6 is stated is that you have to demonstrate financial responsibility but not a liability transfer mechanism. So the only example of a sort of large-scale liability transfer that I know of in the United States is that in order to be competitive in the original FutureGen project, both the state of Illinois and the state of Texas passed legislation that said that they would take liability for the stored CO2. That is not something that has taken place at our project. Our project is located on private land.
Sally, several questions involve the international arena, and to the extent that you can answer these, can you summarize any key differences between the U.S. and EU regulatory process regarding public engagement? And the second question is in your opinion, would the Class 6 be a suitable model for an international standard, and how might an international organization supervise a permitting program? If you could share your thoughts about those questions.
Wow, you know what? I'm going to punt, and I'm going to tell whoever wrote that question or that group of questions to ask Steve Carpenter that question the next time that you meet, because Steve is talking about the International Standards Organization 265, the ISO 265 standard setting process, which I think is a really good place to kind of discuss that process. And Steve is, I'm a part of that process, but Steve is the person who is the designated liaison for the United States. Canada went through a standard setting process not too long ago. So while I think that there's much to be learned from the U.S. regulatory process, you also have to take into consideration many of the factors that are individual amongst different countries and how those, the country context in which you're operating impacts the regulation of underground injection, and what sort of regulatory activities you have in place. I saw that Andrew Gilder is one of your speakers in this tutorial as well. And so Andrew knows quite a lot about the regulatory framework in South Africa, which is primarily centered around extraction and mining and that sort of thing. So you have to look at what regulations and what regulatory framework exist within the country before you can say whether or not the U.S. model is applicable. I think one of the major differences with the U.S. and many of the countries I know around the world that I already mentioned is this idea that in the U.S. we own the subsurface and the government does not.
Another question came in asking about whether or not in the U.S. there's a transfer mechanism, a transfer requirement for liability as in the EU. I will also save these comparative questions for Steve, and they'll be asked at the beginning.
I think the answer to that is no.
I believe that is right.
Yeah, I was going to actually, Craig, I was going to defer that to you, but I'm pretty sure the answer to that is no.
Yeah. We did receive a question about the state of Illinois, and if you could answer why the state of Illinois did not elect primacy in the Class 6 permitting process. And Sally, you may also want to just briefly explain the concept of primacy.
Okay. So primacy, however you want to say it, means that a state has the authority to regulate within their state as long as they meet or exceed the federal regulations for whatever it is that they are taking responsibility. So that is what primacy means. So if you look back at that map that I had when this gets reposted, or you have access to the PDF of my slides, you'll see that different states have different levels of primacy. Some don't have it at all, and some have mixed. They only have oil and gas for Class 2s. Some only have it for Class 1s. Some have it for all. The only states that I know that have elected to apply for primacy for Class 6 are Wyoming and North Dakota. And as far as I know, Illinois did not choose to go for primacy for a couple of reasons. One, because this class of wells is so new, I think there is a certain amount of wanting to wait to see what the federal, regional, and headquarter EPA process was going to be. So in other words, it was too unprecedented to do themselves. The other is that over the years, the funding for the underground injection control program for each state has diminished. And so I do not think that they wanted to take on something that was so potentially involved so much work because it was so new.
Thank you, Sally. Now that is the balance of the questions, I believe. Sally, thank you very much for your presentation as well as for responding to each of those questions.
Thank you.
If we have not addressed any of the questions that any of you have, please, you can submit your any additional questions as well through the intranet. The recording of this webinar and will be made available on the public website in the coming days. We will also post a quiz that will be posted on the internet. This is really just for you to test your own knowledge. We will then, within a few days afterwards, post model answers. I'd like to remind you that the next session is next week, and as Sally said, it's with Stephen Carpenter, Vice President of Advanced Resources International. The topic will be the development of international standards for CCUS. Thank you, Sally, once again, and this concludes our webinar for today.
Thank you.
Thank you.